Okay, so the next very important skill is the grams and moles conversion. So this is our third stoichiometry video, and I'm going to review how to convert between grams and moles. So first things first, we are going to convert 2.67 moles of magnesium nitrate to grams. So what you want to know is you want to start with your givens. So the first bit of given information that I have is 2.67 moles. And then what it's telling me is I'm working with magnesium nitrate. So the very next thing that I want to do is I want to write the chemical formula for magnesium nitrate. So magnesium is Mg and it's in group 2, so it has a +2 charge. Nitrate is a polyatomic, which has a formula of NO3 and a charge of -1. So I'm going to crisscross this to get MgNO3, 2. And then the very next thing that the problem is telling me to do is it's telling me to convert to grams. So I'm going to write little g is equal to question mark. So this is where you want to start mapping out the steps that you need to take in order to get where you want to go. So I'm starting with moles and I'm converting to grams. In the very last video, we practiced calculating molecular weight. The reason for that is molecular weight, MW, is how you bridge the gap between moles and grams. So what that means for us is our very next step is to figure out what the molecular weight of magnesium nitrate is. So we're going to list off each atom and how many there are. So first things first, I have 1 magnesium. But here's the tricky part, is I have these parentheses and this 2 out here. So you're essentially going to distribute in this 2 to each of those terms. So that means I have 2 nitrogens, and that means I actually have 6 oxygens. Oops. Then the very next thing that I'm going to do is I'm going to multiply it by the atomic mass of each of these atoms. So magnesium is 24 grams per mole, nitrogen is 14 grams per mole, and oxygen is about 16 grams per mole. What I'm going to do is I'm going to multiply out all of these numbers and then add them all together. And I'm just going to punch this into my calculator. And I get 148 grams per mole. Okay, so once we do that, we have all the necessary information we need to solve this problem. So what you're going to do is you're going to take that given value, 2.67 moles, and you're going to write it over 1 as a fraction. Then what you're going to do, when you see the word conversion, really for my class, you're probably going to be using fractions, so you want to set up another fraction. And what you're going to do in this fraction is you're going to cancel out moles. So the way you cancel out moles is by dividing it out on the bottom. And so because we're converting from moles to grams, that means grams has to go on top. That way, when you multiply that out, that unit is going to go away. So now what you want to do is you want to go to your molecular weight. And now you just want to match the numbers. So your molecular weight is saying that there are 148 grams for every 1 mole. So 148 goes with grams and 1 goes with mole. So that means we're just going to multiply these numbers together to tell you how many grams are in 2.67 moles of magnesium nitrate. And with 3 sig figs, we should get 395 grams. All right. So number 2, we're going to go backwards. So number 2 says convert 104 grams of sodium chloride to moles. So let's start with our givens. First things first, we have 104 grams. The next thing we're told is we have sodium chloride. So I know that sodium is Na, it has a charge of +1. Chlorine is Cl, it has a charge of -1. So when you crisscross, you get NaCl. Then the next piece of information is it's telling us to convert to moles, so mole equal question mark. And just like last time, we want to make a map of where we are and where we're going. So we're given grams, and we're trying to get to moles. And again, like I told you in the last video and in the last problem, the way you bridge the gap between grams and moles is through molecular weight. So what that means is our very next step is to figure out what the molecular weight of sodium chloride is. So we have Na, there's one of them. Cl, there's one of them. Multiply that by the atomic masses of each of them. And you get 58 grams per mole. So once you have the molecular weight, you can set up the problem. We're given 104 grams, so we're going to put that over 1. Then we're going to set up another fraction, but this time in this fraction, I want to cancel out grams. So if grams is on the top on the left, then on the right, it has to go on the bottom. That's the only way you can cancel out this unit. So then what that means is mole has to go on top because that's what we're converting between. And so this molecular weight, what it's saying is that there are 58 grams for every 1 mole. So 58 goes with the grams and 1 goes with the mole. And with 3 sig figs, we get 1.79 moles.